difficulties, and I am not the greatest at editing, so we're just gonna have to make this a two-part video. So continuing on with number 12, 72 pi plus 161 plus 72 pi plus 89 pi is 161 pi. And for some, so when you guys get 72 pi plus 89 pi, you'll get 161 pi, all over 36. And you'll be able to see that that is exactly the angle that they're asking if both are coterminal. So since we were able to add by 2 pi over and over and over again, and then we figured out that we did get 161 pi, we know that both of these are coterminal, so yes. Alright, 13. Find a coterminal angle between the 0 and 360. So if you guys were given negative 330 degrees, you need to find another coterminal angle that's between 0 and 360. Well, negative 330 is not between 0 and 360, but we can find another coterminal angle by adding by 360. And if we do that, we get a coterminal angle of 30 degrees. 30 degrees is between 0 and 360, so that is the other coterminal angle. So 14. Now for 14, it's negative 435. Not a problem, so let's add by 360 because we know we can find infinite coterminal angles by adding or subtracting by 360. So negative 435 plus 360, we're going to get negative 75 degrees. Now is negative 75 degrees in between 0 and 360? No, so that means we should add by another 360. And when you do this, you're going to get 285 degrees. And 285 is between 0 and 360. So that is what we have. Alright, 640. Now, 640 is not in between 0 and 360, so you have to find another coterminal angle that's between there. Well, doesn't make sense to add by 360, right? Because then that's well past 360, so we want to subtract by 360. So 640 minus 360 will give us 280 degrees. And 280 is between 0 and 360, so that's the correct coterminal angle. Negative 442, we should add by 360. Negative 82, and negative 82, we should add by another 360. And we get 278, and 278 is in between 0 and 360. So there's those. 17, 18, 19, and 20. Alright, so now we're in with radians, right? So 17. Now, if you guys are not used to your radians yet, then you should convert these into degrees. Now, I know that this is above 2 pi. It's because since it is a denominator of 3, I know that if it's pi over 3, right? I know 2 pi would be if it was double this denominator. So in the numerator it would be 6. So 6 pi over 3 is the 2 pi for this case. And since 6 pi over 3 is 2 pi, 11 pi over 3 is well surpassed 6 pi over 3. So then that gives me the indication that I should subtract by 2 pi. Now, so then you would subtract by this amount. And that would give us 5 pi over 3. And 5 pi over 3 is in between 0 and 2 pi, so it would be that. Now, that is how you can do it using radians. Another way you can do it is if you converted this into degrees. So these would cancel, these would cancel, so our left width would be 60. So 11 times 60 is 660. So we know 11 pi over 3 is 660 degrees, which is well surpass 360, right? Because that's what 2 pi is, 360 degrees. So if you subtracted 360 from that, 300 degrees would be in the realm between 0 and 2 pi. But then you guys would need to convert this back into radians. 60 can go into both of those. So 180 divided by 60 is 3, 300 divided by 60 is 5. So then you would get 5 pi over 3. But see how if you convert it from radians to degrees, how much longer it would take to get to that? So if necessary, you can do that, but I would definitely try to get used to your radians. So if 18, right? So I'm looking at 18, and generally I would like to know, okay, if it has a denominator of 18, what's considered 2 pi for something like that? Well, double of 18 is 36. So 36 pi over 18 would be considered 2 pi. So this is not in between 0 and 2 pi, so that means we should add this by 2 pi. So let's add it, and we get negative 35 pi plus 36 pi is pi, and then keep the common denominator. So pi over 18 is in between 0 and 2 pi. So 19. Now, right, we should be subtracting or adding by 2 pi. Now, for 15 pi over 4, let's think about what is 2 pi when it has a denominator of 4. Well, we know the denominator is 4, so what's double of 4? Well, that's 8 pi over 4. Double of 4 is 8, so we know this is equivalent to 2 pi, so that means we should probably subtract from this amount. So we get 15 pi minus 8 pi, 7 pi over 4. And 7 pi over 4 is between 0 and 2 pi, so that is our coterminal angle. 20, so we should probably be adding by 2 pi here, right? So what is 2 pi in terms of when it has a denominator of 12? Well, double of 12 is 24, so 24 pi over 12. This is equivalent to 2 pi. So we're going to add it to that, and we're going to get 5 pi over 12, and 5 pi over 12 is in between 0 and 2 pi. Alright, last one. Find a positive and negative coterminal angle for each given angle. So if we have degrees, we're going to be adding by 360 or subtracting by 360 to find out all our coterminal angles. For radians, you have to add by 2 pi and subtract by 2 pi. So let's see what 2 pi is when it has a denominator of 4. So double of 4 is 8, so 8 pi over 4. So this is equivalent to 2 pi. Now we need to add this or subtract it from there. So 5 pi over 4 plus 8 pi over 4 is 13 pi over 4. So this is coterminal angle because we added by 2 pi, which is also adding by 360. And we need to do 5 pi over 4 minus 8 pi over 4. So that's going to be negative 3 pi over 4, which is the coterminal angle that's negative. Same thing for 22. We have to think what is the 2 pi in terms of having the denominator of 36. So what's double of 36? 72. So this is what 2 pi looks like when it has a denominator of 36. So let's add that to that angle and let's subtract it. So 25 pi over 36 plus 72 pi over 36, that's going to be 97 pi over 36. That's 1. Now we should subtract it from 25 over 36 in order to find the negative coterminal angle. 25 minus 72 pi, that's negative 47 pi over 36. Alright, so that's your guys' homework on coterminal and reference angle.